This video will include naming acids and bases and how to write formulas for acids and bases. First of all, a review. Arrhenius acids and bases. And remember that an acid will contain hydrogen and form hydrogen ions when in solution. For a base, it will contain hydroxide groups which will form hydroxide ions when in solution. Two different types of acids that we can name. The first one will be a binary acid. Bi means two, just like bicycle. Here's hydrochloric acid, hydrobromic acid, hydrofluoric acid. Next kind of acid is an oxyacid. It's called oxyacid because it contains oxygen. There's sulfuric, nitric, phosphoric. Okay, for naming binary acids, which contain hydrogen and one other element, use the word or use the prefix hydro to name the hydrogen part of it, and then you're going to use the root of the nonmetal with an IC ending. Here's our example. HCl. For the hydrogen, we'll use hydro. The root of chlorine is taken away, and we replace it with an IC. This would be hydrochloric acid. Another example, HI. Once again, hydro for the hydrogen. The second element is iodine, so we'll take the ending of the iodine and replace it with an IC, hydroiodic acid. Here's some practice. At this point, go ahead and pause your video, name the following acids, and when you've finished, restart to check your answers. When naming oxyacids, name the polyatomic first. If the polyatomic has an ATE ending, it will be changed to an IC. If the polyatomic ends in ITE, the name of the acid will end in OUS. The saying is to help you remember how to change the ending of the acid name. There's the NO3, which is nitrate, and the ending will be replaced with an IC. So this would be nitric acid. The polyatomic for this is nitrite. Once again, we'll get rid of the ending and replace it with an OUS. This would be nitrous acid. If it ends in ATE, the acid will end in IC. If the polyatomic ends in ITE, the ending will be OUS. 8 goes to IC, height, changes to US. Notice for these we don't use hydro. Okay, once again, some practice. Pause the video and name the following. When you've finished, restart the video and then check your answers. Now that wasn't so bad. Naming bases is a lot easier. First of all, you name the metal, and then you name the hydroxide. That's all there is to it. Done. Example here, Na and OH. Na is named, that's sodium, and then the OH is named hydroxide. Name of the metal is calcium. And the second part, hydroxide. Okay, this is your practice, so go ahead and pause the video and then come back and check your answers. If we're writing the chemical formula from the name, first of all, we need to identify if it's a binary acid or an oxyacid. If it's binary, we need to determine what nonmetal it's going to be. If it's an oxyacid, we need to determine what the polyatomic is. We're going to then add the correct number of hydrogens according to the charge of the polyatomic or the nonmetal. Remember, this is the same as the oxidation numbers. Here's some examples of acids. If we have the name, hydrosulfuric and sulfuric acid. Notice that the first one is binary because it starts with the word hydro. The second one is a polyatomic. There's a hydro, there's our H. Sulfuric, sulfur is an S. So then we need to find the oxidation number of sulfur. Right here, periodic table, there's our sulfur. Looks like it's going to be a -2. So that means that's going to have 2 hydrogens to offset the number of negatives that we have. For our oxyacid, sulfuric, what was the polyatomic that it came from? No hydro, so it had to be a polyatomic. And the ending is an IC, so we'll kind of work our way backwards. That means that the polyatomic would have had to have an AT ending. Looking at our reference sheet, our polyatomic list, we find that we see sulfate, ATE, sulfate. So notice that it has an oxidation number of -2. So it means we've got to replace it with 2 hydrogens. So our formula there is H2SO4. Writing a formula for a base. Once again, identify the metallic, add the correct number of hydroxides according to the oxidation number. Look at an example here. We have barium hydroxide and lithium hydroxide. Let's look at barium hydroxide first. There's our Ba for barium, and there's our OH. Look in our periodic table, find barium, there it is. It's in the second column, it's in the 2A column. Remember that anything in the 2A column has a +2 oxidation number. So that means we're going to have to replace the +2 with 2 hydroxides. Looking at our next example, there's our lithium and then our hydroxide. Go back to our periodic table, find our lithium, and notice that everything in the 1A column has a +1 oxidation number. So our formula is going to be LiOH, 1 for 1, just a 1-1 ratio. For summary, when naming binary acids, we're going to use the prefix hydro and the root and then an IC ending. Oxyacids, these are the ones that have oxygen, or the polyatomics, we're going to use the name of the polyatomic. If the polyatomic has an AT ending, we're going to change it to IC. If the polyatomic has an IT ended, we will change it to OUS. Writing formulas, we're going to determine the oxidation number and replace the oxidation number with the corresponding number of hydrogens. So in other words, if we have 1 minus, that we're going to replace it with 1 hydrogen. 2 minus, replace it with 2 hydrogens. 3 minus, replace it with 3 hydrogens. For base naming, first of all, name the metal, then name the hydroxide. For the base formulas, identify the metal oxidation number and replace it with a corresponding number of hydroxides. After viewing this video and taking notes, you should be able to do the acid-base naming